लिमिट्स L4 एंड L5 में हमने इनडिटर्मिनेट फॉर्म ऑफ द टाइप 0 by 0 एंड इन्फिनिटी by इन्फिनिटी देखा। नाउ आज के इस वीडियो में हम इनडिटर्मिनेट फॉर्म्स ऑफ द टाइप 0 into इन्फिनिटी देखेंगे। नाउ इफ लिमिट x approaches to a fx into gx is such that limit x approaches to a fx equals 0 and limit x approaches to a gx equals infinity, then the product limit x approach to a fx into gx assumes the form 0 into infinity type. The indeterminate form limit x approaches to a fx into gx, which assumes the indeterminate form of the type 0 into infinity, is converted into 0 by 0 form or infinity by infinity form by the following relations. So we write f of x into g of x as, so we can write this as, when we convert this into 0 by 0 form or infinity by infinity form, so we write fx into gx as fx divided by 1 over g of x, or we can at the same time write this as gx divided by 1 by f of x. So एक example देखते हैं, limit x tends to infinity x into tan of 1 by x. Now first we'll check whether this is an indeterminate form of the type 0 into infinity. So x infinity को जा रहा है, so this will be infinity. Tan of 1 by infinity is 0, so it will be tan 0 is 0, so this is infinity into 0. Or we can alternatively write, we can flip this x tan of 1 by x by commutative property. We can write this as limit x tends to infinity tan of 1 by x into x. By commutative property, x tan of 1 by x will be same as tan of 1 over x into x. So this is an indeterminate form of the type 0 into infinity. Now in order to solve 0 into infinity form, we convert this form into 0 by 0 form or infinity by infinity form by the following relation. जैसा कि हमने पहले देखा, fx into gx अगर indeterminate form of the type 0 into infinity है, then इसको 0 by 0 form या infinity by infinity form में convert करने के लिए we write fx into gx as fx divided by 1 over g of x, और हम ऐसा भी लिख सकते हैं gx divided by 1 over f of x. अगर fx का वैल्यू हम x दे and gx will be taken as tan of 1 by x, then we can write this as limit x tends to infinity tan of 1 by x divided by 1 by x. Now when x tends to infinity, so it will be tan of 1 by infinity. 1 by infinity is 0, so it will be tan of 0, which will be 0, and 1 by infinity, which will be again 0. So this has been now reduced to 0 by 0 form. That means we can solve this 0 by 0 form by L'Hopital rule. So solving by L'Hopital rule, we have already gone through L'Hopital rule and limits L4 and L5, and we know while solving the indeterminate form of the type 0 by 0 or infinity by infinity, we differentiate the numerator and denominator separately. So we'll be differentiating numerator and denominator separately here as well. So we can write limit x tends to infinity tan of 1 by x की differentiation, so it will be sec square 1 by x, and 1 by x की internal differentiation by function of function c, so it will be minus 1 by x square divided by 1 by x की differentiation minus 1 by x square. So minus 1 by x square से ये minus 1 by x square cancel होगा, so we'll be left with limit x tends to infinity sec square 1 by x. Now we can use the limit, so it will be sec square 1 by infinity, which will be sec square 0, so which will be 1 square, so it will be 1. So next example is limit x tends to 1 minus x into tan of pi into x divided by 2. So you can first of all check कि indeterminate form of the type 0 into infinity है या नहीं. So when x approaches to 1, so it will be 1 minus 1, which will be 0. So tan of pi into 1 divided by 2, which is tan pi by 2, which means we'll obtain infinity. So this is an indeterminate form of the type 0 into infinity. So this is 0 into infinity form. Thus we can write this as limit x approaches to 1, 1 minus x divided by 1 minus tan of pi into x divided by 2. As we know, fx into gx can be written as fx divided by 1 over gx. So 1 over gx को अगर हम फिर से reciprocal में लाएं, so it will be same as fx into gx. Now we can check कि एक particular indeterminate form obtain हो गई है या नहीं. X approaches to 1, so it will be 1 minus 1, which will be 0. 1 divided by tan of pi divided by 2. Tan pi by 2 is infinity, so it will be 1 by infinity, which is 0. So that means this is reduced to 0 by 0 form. And alternatively, we can write this as limit x tends to 1, 1 minus x divided by 1 by tan of pi by x by 2. We can write this as cot of pi x divided by 2. So because the tan is the reciprocal of cot, or cot is a reciprocal of tan. So now this is a 0 by 0 form, so that means we can solve this 0 by 0 form by L'Hopital's rule. We already know कि L'Hopital's rule में हम numerator and denominator को separately differentiate करते हैं. So differentiating numerator and denominator, so it will be limit x approaches to 1, so 1 minus x, so this will be minus 1 divided by cot of pi x by 2 की differentiation, so it will be minus cos x square pi x by 2 into pi x by 2 की differentiation, so that will be pi divided by 2. So next we can proceed as pi by 2 बाहर आएगा as 2 by pi. Limit x approaches to 1, minus and minus will cancel out, so we'll be left with 1 divided by cos x square pi into x divided by 2. Now we can use the limit, so it will be when x approaches to 1, so it will be 1 divided by cos x square pi into 1 divided by 2, so it will be 1 divided by cosec pi by 2 whole square, so which means it will be 2 pi into 1 by cosec pi by 2, so it will be 1 divided by 1, so it will be 2 divided by pi. The next example is limit x tends to 0 from the right, x raised to power m into log of x raised to power n, where m and n are positive integers. In fact, this is a more generalized result where m may be less than n, m may be greater than n, or m may be equal to n. So which means if we are computing limit x approaches to 0 from the right, x raised to power m into log of x raised to power n, इसका limiting value 0 होगा in all the cases where m is greater than n, m is less than n, or m is equal to n. So which means अगर हम ऐसा कोई limit ले, limit x tends to 0 from the right, x square into log of x raised to power 4, limiting value 0 होगा. Next, if we write limit x tends to 0, x raised to power 4 into log of x square, फिर से limiting value 0 होगा. Limit x approaches to 0, x square into log of x square, इसका भी limiting value 0 होगा. So in all cases when we have x raised to power m log of x raised to power n, when x tends to 0, so इसका limiting value 0 होगा. Now let's simplify this. So we can write this as limit x approaches to 0 from the right. So this will be log of x raised to power n divided by 1 divided by x raised to power m. which will be again limit x approaches to 0. पहले हम चेक करते हैं कि कौन सी indeterminate form है ये. So log of x raised to power n when x approaches to 0. So this will be log 0, which will be infinity 1 divided by 0. So it will be infinity by infinity form. And alternatively, we can write this as limit x approaches to 0 log of x raised to power n divided by x raised to power m को अगर ऊपर ले आए, so it will be x raised to power minus m. Now this is indeterminate form of the type infinity by infinity, so we'll be finding the limiting value by using the L'Hopital rule, so in which we differentiate the numerator and denominator separately. So we can write this as limit x approaches to 0 from the right. अब log of x raised to power n की differentiation कीजिए, so it will be n times log of x raised to power n minus 1 into log of x की internal differentiation by function of function से, that will be 1 by x divided by x raised to power minus m की differentiation, it will be minus m x raised to power minus m minus 1, which can be written as minus 1 raised to power 1 n divided by minus m को बाहर ले आएंगे लिमिट से, so it will be minus 1 raised to power 1 into n by m into limit x approaches to 0 from the right. So it will be log of x raised to power n minus 1. So 1 by x को हम ऐसे भी लिख सकते हैं x raised to power minus 1 divided by x raised to power minus m into x raised to power minus n, x raised to power minus m into x raised to power minus 1. So it will be x raised to power m minus 1 basis का add करके. So x raised to power minus 1 से ये x raised to power minus 1 cancel होगा. So therefore we'll be obtaining minus 1 raised to power 1 into n by m into limit x approach to 0 from the right. So log of x raised to power n minus 1 divided by x raised to power minus m. अब फिर से indeterminate form of the type infinity by infinity obtain हुई. So that means we can again differentiate it by using L'Hopital rule. So we can again differentiate numerator and denominator. So it will be minus 1 raised to power 1 n by m limit x approaches to 0 from the right. So log of x raised power n minus 1 की differentiation, it will be n minus 1 into log of x raised to power n minus 2. So log of x की फिर से internal differentiation 1 by x divided by x raised power m की differentiation minus m x raised to power minus m minus 1, which can be written as minus 1 raised to power 1. अब ये minus 1 फिर से बाहर आएगा, so it will be minus 1 whole square into n into ये n minus 1 फिर से multiply, so n into n minus 1 divided by m and this m again, so it will be m square into limit x approaches to 0 log of x raised to power n minus 2 divided by x raised to power minus m into x raised to power minus 1. 1 by x को हम फिर से as x raised to power minus 1 लिखेंगे. So x raised to power minus 1 से फिर से ये x raised to power minus 1 cancel होगा. So x raised to power minus 1 से फिर से ये x raised to power minus 1 cancel होगा. So we'll be left with minus 1 whole square into n minus 1 divided by m square into limit x approaches to 0 from the right. So log of x raised power n minus 2 divided by x raised to power minus m. Now again we have obtained indeterminate form of the type infinity by infinity, which means we'll be again differentiating this by L'Hopital's rule. Now again applying L'Hopital rule, so this will be minus 1 whole square into n minus 1 divided by m square into limit x approaches to 0. फिर से differentiation of the numerator divided by the differentiation of the denominator. So log of x raised power n minus 2 की differentiation n minus 2 into log of x raised to power n minus 3 और log x की फिर से differentiation 1 by x x raised power minus m की minus m into x raised to power minus m minus 1. Now again we can write this as minus 1 square से फिर ये minus 1 combine होगा, so this will be minus 1 cube into n minus 1. अब फिर से n minus 2 लिमिट से बाहर आएगा, so it will be n minus 2 divided by m square into m, so it will be m cube into limit x approaches to 0 from the right, log of x raised power n minus 3 divided by 1 by x को हम फिर से ऐसे लिखेंगे x raised power minus 1 और x raised power minus m minus 1 को फिर से x raised power minus m into x raised power minus 1, फिर से x raised power minus 1 और x raised power minus 1 cancel होगा, so we'll be again left with x raised power minus m. Next we will be continuing this process as we have again obtained infinity by infinity form, so we will be continuing this process and we will be differentiating this n times. But up to now we have obtained some sort of induction क्योंकि यहाँ पे हमने 3 times already differentiate किया है, so this will be minus 1 raised power 3 m raised power 3, यहाँ पे log of x raised power n minus 3. So जब हम n times differentiate करेंगे, so it will be minus 1 raised power n into n minus 1 into n minus 2, यहाँ पे 2 आया, so lastly we will be obtaining 3 into 2 into 1 divided by फिर से यहाँ पे m cube, so when we will be differentiating n times, so we will be obtaining m raised power n into limit x approaches to 0 from the right, so log of x raised power n minus 3, so it will be n minus n divided by x raised to power minus m, so which is minus 1 raised to power n into n minus 1 n minus 2 up to 3 into 2 into 1, which will be n factorial divided by m raised to power n into limit x approaches to 0 from the right, so log of x raised power n minus n, so it will be log of x raised to power 0 divided by x raised to power minus m, which will be minus 1 raised to power n into n factorial divided by m raised to power n, so log of x raised power 0, which will be 1, so it will be limit x approaches to 0 from the right 1 divided by x raised to power minus n. Now we can write this as minus 1 raised to power 1 into n factorial divided by m raised to power n into limit x approaches to 0, so 1 divided by x raised to power minus m को हम ऐसे भी लिख सकते हैं x raised to power m, so when x approaches to 0, so it will be minus 1 raised to power 1 into n factorial divided by m raised to power n into when x approaches to 0, so it will be 0 raised to power m, so this whole thing will be 0, which means the limiting value of limit x approaches to 0 x raised to power m into log of x raised to power n, where m may be different from n or m is equal to n. In both cases the limiting value of this function will be 0.